Hi, this is SS 7.1, an understanding of circles. So we're talking about circumference and central angles. So characteristics of a circle, so knowing what pi is and knowing that the angles all add up to 360 and knowing that there's relationships like the area is equal to pi times the radius squared and that the circumference is equal to pi times the diameter. So those are kind of the characteristics of a circle. Define and illustrate the relationship between the diameter and the radius, and so you should know that a diameter is all the way across and a radius is halfway across. Answer the question, how many radii does a circle have and why? Well, I guess it could have unlimited amounts because we could draw them all day long, right? And how many diameters? Same thing. We can draw them from any, they're supposed to go through the center though, unlike my horrible drawing. Explain with illustrations why a specified point and radius length, or diameter length, describes exactly one circle. So if I said the radius is 7, draw me a circle. Well, you could draw, especially with a compass, a radius of 7. So we'll say that that is 7. And then keep your point of your compass in the center. And then you could draw that circle so that it's 7 in any direction. So there can only be one size of circle given a specified point, that blue dot, and the radius length. I gave you 7 for this example. Illustrate and explain the relationship between a radius and a diameter. We just did that. Generalize from investigations the relationship between the circumference and the diameter. And so this is what those Greek guys did way back when, sitting around in their basement drawing circles, and they realized that for every circle they drew, the circumference, the distance around, right, that's the perimeter of the circle, was exactly the diameter times 3.14. And so you can estimate problems with circles by just using 3 as your pi. And so if we took the diameter and times it by 3, that would give you a rough estimate as to the whole perimeter of the circle, the circumference. Define pi, explain how it is related to circles. So we have some interesting history coming up regarding pi. Sort a set of angles as central angles of a circle or not. And so they've said here that the sum of central angles have to add up to 360. So for example, if I have a circle here and this is 90, then we should know that the rest of this is 270, right? Draw a circle with a specific radius or diameter with and without a compass. So if you're going to do it with a compass, that's easy because you just do kind of what I did up here with my blue circle. But if you're going to draw it without, you'd have to draw your central point, 7, 7, 7, 7, whatever the radius is that they've given you. Draw enough of them that you can kind of connect the dots and draw your circle freehand, connecting all those dots. Maybe draw it nicer than mine. All right, so here we have pi. These are the characteristics of your circle, that the radius is half the distance across, the diameter is the full distance, and circumference means the perimeter. We need to memorize the formula for area. An area would be if I'm going to cover this whole circle with carpet, right? I would need to know the area. And that's a two-dimensional, it's kind of like length and width of a circle, right? So that is why we have squared on here. It's a two-dimensional measurement. Circumference is actually a linear measurement. If I took, let's say, this blue section all the way around, if I unraveled it, really it's just a long string, right? It's linear. It's just a one-dimensional, that's why there's no squared exponent on there. It's one-dimensional. It's just length. And here is the history lesson. So this is Archimedes, and it says, everyone knows me for my famous exclamation, Eureka, I have found it. So he was the original guy that said Eureka, and that's something that scientists just sort of joke about when they find out stuff. They say Eureka. It's like, oh my gosh. So apparently King Hiron of Syracuse, this is back in Greece, had ordered a golden crown to offer to the gods, and this guy, the blacksmith, made him a crown, and King Hiron didn't trust him. It says, I don't trust that blacksmith. So he told Archimedes to find out if the crown was really gold, but he couldn't just melt it down and test the metal. So Archimedes had to figure out a way to test if the crown was gold or not. So that night he had a bath, and when he got in the water, he realized that the water all displaced because the weight of his body took up space where the water should have. So all of a sudden, in the middle of his bath, he had this brainwave, Eureka, Eureka! And he realized that, and apparently he did run out into the middle of the street with nothing but his bubbles on. And he said, immerse the piece of gold with the same weight in water. Measure how much water is displaced. So they took a real piece of gold, like a gold bar, that weighed the same amount as the crown. They put them both in water, and if it displaced a different amount of water, then it wasn't pure gold, that there was something else in the mixture of the crown that was a bit lighter and cheaper. And it says, in the end, the goldsmith had indeed cheated and was punished. And I like King Hiron says here, very clever. Now, please put on some pants. So there's a little tidbit about Archimedes. He's a pretty brilliant dude. So the other thing that Archimedes is famous for is he kind of invented pi. And I don't know if he really meant to, but he was really trying to find the square root of 3. He knew that the square root of 4 was equal to 2. And he knew that the square root of 9 was equal to 3. So he was trying to find the square roots of all the numbers in between 4 and 9. And he came up with some brilliant ideas. So one of them was that he was drawing circles. And he figured out that there was a ratio of a circle's perimeter, so that's the circumference, right? Same thing. To its diameter, and that is the distance across. And he said he kept coming up with the same ratio. It was exactly the same number that he kept getting. So when he did circumference to diameter, he kept getting this number, 3.14 yada yada yada. Now back then they didn't have decimals, so he would have had just fractions to work with. And then when he compared it to the circle's area compared to the square of the radius, so he took area compared to the square of the radius, he also got that same number. Now he was using fractions, so he knew that it was more than 3 and 1/7, but less than 3 and 10/71. So in between 3 and 1/7 to 3 and 10/71. That's where he figured this number lied. And so he figured out that this special number, which we now call pi, if you multiply pi times the diameter, you'll get the circumference, and if you take pi times the radius squared, you'll get the area. So the other thing that Archimedes invented was pulleys and levers, and so he's stepping on the end of his simple type 1 lever here, lifting up this brawny soldier. And the soldier says, bro, do you even lift? And he says, I do, yes, sometimes I do. So it doesn't take much force on this end to lift the soldier if the rock is closer to the soldier. That's what he figured out. Smart guy. Okay, central angles add up to 360. We've talked about that. So if this section is 90, we can tell because it has the square here. And this section is 50. We can add those two together. We get 140. And so angle X, all we do is subtract what we know from the total of the circle. So does that sound right? So angle X would be 220 degrees. All right, so just to review real quick, you need to know that everything adds up to 360 degrees. You need to know that circumference is pi d and that area is pi r squared. Good luck with circles.